In this session, we're going to look at lessons 84, 85, and 86. In lesson 84, there are two parts to it. The first part is, you guessed it, trig identities, trig proofs, part 3. You need to go to page 504. You need to write all those down. We will try and put those down on the board for class. I'm not going to go over those. You know how to do trig identities. They simply gave you more to look at. We can look at these more in class if you need to. The next thing we're going to look at in lesson 84 is graphing sinusoids, cosine functions, sine functions, either one. Now, before they gave you the graph, and you had to create the equation from the graph. Now we're going to take the equation and graph it from what they give us with the equation. Now, they give us y equals -10. First thing we need to find out, sine function, positive or negative. We will notice that it has a period of 3 and a phase shift of -45. So let's start with where to put the origin. So it's going to be a perfect positive sine function, except actually we got to start with the period. The period is 3. So it is 360 divided by 3, so the period is actually 120. So it's going to be 120 from start to finish. So a full deal here is going to be 120. So what's that going to look like? Well, let's start with what 0 degrees. 0 degrees would be right here. We'll back it up 45 in a minute. All right. Let's pretend, this is the way I like to do it. Pretend that it's a perfect sine function, just like this, where it goes right through the middle. Now, we know it's not, but let's go with that. So 120 would be a full right here. So this would be a full look at what this is. So this would be 60 right here. This would be 0 degrees, obviously. So here in the middle, these are 60 apart. So half of this would be 90 right here. And this would be 30 degrees. So that means this is -30. This is -60. This is -90. This is -120. So it gives you kind of an idea. So when we back this thing up 45 degrees, it's going to look a little different. So whenever we look at this problem here, we're going to note that this is going to back up, and it's going to be somewhere about right here. It's easy to get our center line is going to be at -10. So when we do our top and our bottom here, this is -10. So it'll be up to be -8. This will be -12 because 2 is our range. It is a sine function. It's 45. So we got this. We've got to make some adjustments to our numbers here. All we got to do is, since we backed up 45 degrees, we had to adjust all of our numbers a little bit. We had to subtract them all by 45 degrees. But this is how you graph a sinusoid. Now, in lesson 85, part 1, we're going to see where using these trig proofs actually is going to come into play. And they want you to solve for this. And the way to solve for this is we first are going to rearrange one of our trig proofs to look like tan squared theta equals secant squared theta minus 1. So you get parentheses instead of tan squared theta. We're going to put secant squared theta minus 1 equals 7 secant theta minus 5. So multiply this out, you get 3 secant squared theta minus 3 equals 7, secant theta minus 5. Let's bring everything to this side, so we get 3 secant squared theta. This would be plus 5, so it ended up being plus 2. We get minus 7 secant theta plus 2 equals 0. Now what we're going to do is we're going to end up solving for this. So we're going to get 3 secant theta minus 1. When we break this down, and then the other one is going to be secant theta plus 2 minus 2. So you're going to solve these individually. So we get 3 secant theta minus 1 equals 0. And then we're going to get secant theta minus 2 equals 0. When you do this, bring the 1 to the other side. You're going to end up with secant theta is 1/3. Right here, we're going to get secant theta is 2. Now, when you get down to here, we know that secant is the opposite of cosine. So if you write cosine theta, you have to flip your answer to 3 1/2. Now we know that it can't be greater than 1, that's impossible, so this one is out. So the question is, when is cosine theta 1/2? You know how to solve for this. You will find that cosine theta is 1/2 at 60 degrees, and we know that there's never just 1, there is always 2, so it's going to be 60 and 300 degrees. Lesson 85 part 2 has to do with clocks. And what you need to solve for this is n plus n divided by 11. So really you only need one number in order to solve for these. The first example says the hands of a clock point in the same direction. How many minutes will it take for them to be in the opposite direction? Well, you know, it doesn't matter where the hand of the clock is. So let's say they were going here, they were going in the same direction. How long does it take for them to go in opposite directions? Well, it always takes 30 minutes. Okay, so this 30 minutes plus a little bit. Well, this is how you figure this, is the number you need is 30 minutes plus 30 divided by 11. Okay, so that's 30 plus, this is going to be 2 8/11, so 32 8/11 is the answer. That's all there is to these problems as long as you use this equation. Look at another example. It's 3 o'clock. In how many minutes will the two hands of the clock point in the same direction? Well, you got to know a clock. And if it's 3 o'clock, big hand here, small hand here, because this is 3. And then it wants to know how many minutes we'll have them in the same direction. Well, that's 15 minutes. Well, 15 is our number, plus 15 over 11. So 15 plus 1 4/11. So 16 4/11 is what the number ends up being. So this is all there is to the clock problems. Pretty easy problems. Just remember, it's the number plus the number divided by 11. That's going to give you your answer. All right, in the last lesson, lesson 86, we're going to look at arithmetic progression and arithmetic means. In this first one here, this is a formula you need to write down your formula page. This is the first term. This is the number of the term. And this is the common difference. Okay? And you need those three numbers in order to solve for this. They want you to find the 25th term of a sequence whose first term, they want you to find the 25th term. The first term is 12, and the common difference is -6. So you're going to take these terms and plug them in. You have 12 plus 25 minus 1 times negative 6. 24 times negative 6. You have 12. It's going to be minus. It's going to be 120, 144. Subtract this. It's going to be negative 132. We're going to look 2 more examples, then we'll be done with this video. The next one, it says, insert 3 arithmetic means in between 2 and negative 4. So they want 3 numbers in between these 2 numbers. And you know what? I'm going to switch those so it looks correct on a number line. So this would be the first number. This would be the 5th number. They want you to find numbers 2, 3, and 4. So we use the same formula. If A1 is negative 4, N would be the second number, and we would have to find the common difference. That's pretty easy to do. Let's find the 5th number. Okay, so the 5th number is 2. We know that because it was given to us. A1 would be negative 4. The number, it would be the 5th number, and what we're trying to find is the common difference in order to fulfill this. So 2 equals negative 4. This is going to be plus 4 times D. Add 4 to both sides. You get 6 equals 4D. So divide by 4, divide by 4. So 3 halves is our common difference. So we actually could take this. We wouldn't have to do any more of this. We could take this and add 3 halves to negative 4. 3 halves is the same thing as 1 1/2. So it'd be negative 3. It would be negative 2 1/2. Add 1 1/2 again, it would be negative 1. Add 1 1/2 again, it would be 1/2. Add 1 1/2 again, it would be 2. So these are the 3 numbers in between the 2 of those. But we use this formula to figure out our stuff. All right, now in this next one, they give us A17 is negative 40, A28 is negative 73. They want you to come up with A1, A2, A3, A4, and A5. Well, you can't come up with any of those until we solve for some things. But what you're going to do is you're going to treat this with 2 different equations. So you're going to have 40 equals A1, we don't know. We do know that this was number 17. We don't know the common difference. The next one is negative 73. We don't know A1. We do know that this was number 28, and we don't know the common difference. So this will be 40 equals, this will be 16, so A1 plus 16D. This will be A1 plus 27D. And so all you would do is you would treat this like a substitution elimination problem. And when we do that, we can go ahead and solve for D, because of course we would eliminate. Let's go change all the signs. Negative, the positive, negative, negative. So when you do that, you get 1, 1, 3 equals negative 11D. Divide both by negative 11. Oh, this was supposed to be negative 40. That was my bad. That would have helped everything. Oh, it was negative 40. I just didn't look at that correctly. So whenever I do that, that would be 33. Divide that, negative 3 equals D. So the common difference is negative 3. Let's go back up to right here. If the common difference up here was -3, we could actually solve for this one up here, solve for the A1. So 16 times -3 is, let's see, -40 equals A1. And 16 times -3 is -48. Add 48 to both sides. That cancels. A1 is 8. So now we have A1. We have our common difference is -3. Well, if this is 8, and you're going to add -3 every time, it makes it pretty easy to go 8, 5, 2, -1, -4. All goes back to using this formula right here in order to think it through and solve for these.